Hello friends, welcome to the channel. In this video, I'll solve KSET 2015 Physical Science Paper 2 questions, and here I'll cover question number 26 to 50. The expectation value of potential energy of a linear harmonic oscillator is, as we know, for linear harmonic oscillator, the total energy or expectation value of energy, total energy is given by n plus half h cross omega, and for linear harmonic oscillator the kinetic energy is equal to expectation value of potential energy, and we know that the total energy is given by addition of both kinetic energy and potential energy. Therefore here we can write this as half of expectation value of E total energy, that is half of n plus half h cross omega. Therefore option A is correct. Which of the following states has eigenfunction for hydrogen atom as psi 210 is equal to 1 upon root 32 pi into 1 upon a naught raised to 3 by 2 exponential minus r by 2 a naught cos theta. So generally eigenfunction for hydrogen atom is represented by psi, n, l and m, where n is principal quantum number, l is orbital quantum number and m is magnetic quantum number. Here it is mentioned that it is psi 210. That means the wave function or eigenfunction is represented by psi 210, where value of n is 2, l is 1 and m is 0. That represents 2, l is 1 stands for p state. It represents 2p state. So direct answer, it is 2p state. If this is not mentioned, how to find the wave function or how to find the state of the function? Wave function for hydrogen atom is given by psi nlm. It is a general expression, some constant into e raised to minus r upon n a naught into sin theta raised to l, or sometimes it may be cos theta raised to l into e raised to im phi. Now comparing the given expression with the standard general expression, we can say that value of n is, so comparing this, n is 2, value of l is 1 and m is 0. Therefore this represents 2p state only. Option A is correct. The electron of hydrogen atom is in ground state. The expectation value of position coordinate r is. So here it is mentioned that electron of hydrogen atom is in ground state. So wave function for hydrogen atom is given by psi nlm is equal to some constant into e raised to minus r upon n a naught into sin theta raised to l or cos theta raised to l into e raised to im pi. Here it is mentioned that the electron is in ground state. For ground state, value of n is equal to 1, l is equal to 0 and m is equal to 0. That indicates psi 100 is ground state. It is given by constant. Here constant value is 1 upon root pi into a naught cube into e raised to minus r upon n a naught. Value of n is 1 here, so minus r upon a naught. Sin theta raised to 0 is 1, e raised to 0, value is again 1. Only this much is the wave function for hydrogen atom in ground state. Then we have to find the expectation value of position coordinate r. It is given by complex conjugate of wave function into this, into the wave function integrated over volume element d tau. Here d tau is r square dr sin theta into d theta into d pi, given by 1 upon root pi a naught cube e raised to minus r upon a naught into r into 1 upon root pi a naught cube e raised to minus r upon a naught into r square dr, then integration sin theta d theta integration d pi. So here these are constant, take it outside, pi a naught cube integration, so here 1r, here r square becomes r cube e raised to minus r upon a naught into e raised to minus r upon a naught, just 2r upon a naught with respect to dr, and value of this one will be 4 pi, because their sin theta d theta value is 2, and if you integrate d phi over 0 to, so this here it is 0 to pi and here it is 0 to 2 pi, so here you will get value 2, and for integration of d phi you will get value 2 pi, so total will be 4 pi. Then 4 pi divided by pi a naught cube integration of r cube e raised to minus 2r upon a naught dr. It is of the standard form x raised to n e raised to minus ax with respect to dx. Value of this definite integral is n factorial divided by a raised to n plus 1. Apply for this integral. So here pi and pi cancels, 4 upon a naught. So r cube, value of n means 3, therefore 3 factorial divided by, so here comparing e raised to minus x with e raised to minus 2r upon a naught, so value of a will be 2 upon a naught, therefore 2 upon a naught raised to n plus 1, that is 3 plus 1, 4 upon a naught to 3 factorial, 3 into 2 divided by 2 raised to 4, means 2 into 2 into 2 into 2 divided by, sorry here it is a naught cube divided by a naught raised to 4. So here 4 cancels, 2 cancels, so a naught cube and a naught raised to 4. Therefore, if you simplify, you will get 3 by 2 a naught. So option C is correct. Some other formulas, important formulas are, for ground state of hydrogen atom, expectation value of R is 3 by 2 a naught, then expectation value of R square is 3 a naught square, then expectation value of 1 upon R is 1 upon a naught, then 1 upon R square is 2 upon a naught. These are some standard expressions. The value of sigma square is equal to sigma x square plus sigma y square plus sigma z square is equal to, so here sigma x, sigma y and sigma z are Pauli spin matrices. Pauli spin matrices given by sigma x is equal to 0 1 1 0, sigma y is equal to 0 minus I 0, and sigma z is equal to 1 0 0 minus 1. Here eigenvalues of sigma x, sigma y and sigma z are plus or minus 1. Therefore sigma square is given by 1 plus 1 plus 1, value is 3. Therefore value of sigma square is given by 3. But in options it is not there. instead of that 3 cross square by 4 is there. That is eigenvalue of square of the spin angular momentum matrices S. So spin angular momentum matrices is given by S is equal to h cross by 2 sigma. That is Sx is h cross by 2 sigma x, Sy is h cross by 2 sigma y. Similarly, Sz is h cross by 2 sigma z. Since sigma x eigenvalue is plus or minus 1, eigenvalues of Sx, Sy and Sz are plus or minus h cross by 2. Therefore, S square here is given by Sx square plus Sy square plus Sz square. That is h cross square by 4 plus h cross square by 4 plus h cross square by 4. Therefore, answer is 3h cross square by 4. That is the eigenvalues of square of the spin angular momentum matrices S. A system has two energy levels of energy 0 and 100 kb with degeneracy 2 and 3 respectively. The partition function at a temperature of 100 Kelvin is given that value of E0 is 0 and E1 is 100 into kb. Kb is Boltzmann constant. Then degeneracy of two states, G0 is 2 and G1 is 3. Then temperature is given, that is 100 Kelvin. Now we have to find the partition function. Partition function is given by Z is equal to summation Gi, that is degeneracy, into e raised to minus Ei upon kbt. So if you substitute, so you will get 2 into e raised to 0 for this state, e raised to 0 plus 3 into e raised to minus 100 kb divided by kb into value of t is 100 only, 100. So 100 cancels, kb cancels. So 2 plus 3 e raised to minus 1. If you simplify this one, you will get answer 3.104. Therefore, option C is correct. In a grand canonical ensemble, a system A of fixed volume is in contact with a large reservoir B. Then, so now let us see what is ensemble. Collection of large number of assemblies correspond to same macroscopic state but having different microscopic state is said to be ensemble. So there are three types of ensembles here. So one is canonical ensemble, second one is grand canonical, and third one is micro-canonical. Canonical ensemble is closed one. So here it can exchange only energy, not the number of particles. Whereas in grand canonical ensemble, it is a open system. So here it can exchange both energy as well as number of particles. Then in micro-canonical, it is isolated. There is no exchange of energy and number of particles. Here it is mentioned that it is a grand canonical ensemble. So therefore it can exchange both energy as well as number of particles with the system B. Therefore D is correct. In the variation principle, if a wave function psi of an eigenstate differs from the ground state wave function psi naught by epsilon, then its energy E differs from ground state energy E naught by. So it is mentioned that it is in a variation according to variation principle. Here psi differs from psi naught by epsilon. Then according to variation principle, the expectation value of Hamiltonian is nothing but energy is given by bracket notation of psi h psi is always greater than ground state energy E naught. And for normalized wave function, value of this is always is equal to 1. So here it is given that psi is equal to psi naught plus epsilon. Now substitute this in the variation principle expression. So you will get h is equal to psi naught plus epsilon h psi naught plus epsilon. Here we can consider this as is equal to 1. Therefore it is given by psi naught plus epsilon star h psi naught plus epsilon with respect to d tau. So here integration h into psi naught plus epsilon whole square d tau. You can consider this as amplitude whole square. So this becomes integration h psi naught square d tau plus epsilon square h d tau plus epsilon h psi naught d tau. So value of this is represents the ground state energy plus epsilon square h d tau plus epsilon h psi naught d tau. Therefore the total energy, this is total energy, differs from E naught by epsilon square. Therefore answer is epsilon square. A thermodynamic change takes place in such a way that the entropy either decreases or remains constant. This statement is, so entropy S is defined as dq by T, where dq is increment in heat energy supplied to the system and T is temperature. And also it is noted that the entropy change ds is 0 for reversible process and it is positive for all irreversible processes. Therefore this entropy change may be either 0 or it may increases, but here in this statement it is mentioned that entropy either decreases or remains constant. That is not true. Lambda point transition in liquid helium during Bose-Einstein condensation occurs at, direct question, it occurs at 2.19 Kelvin. An excited nucleus deexcites via transitions among three levels of energy E1 greater than E2 greater than E3. If the rate for E1 to E2 transition is equal to that for E2 to E3 transition and corresponding matrix elements are in the ratio 1:2, the ratio of density of states is. So here according to Fermi-Golden rule, number of transition per unit time, omega nk, is directly proportional to square of the matrix element. So the expression is 2 pi upon h cross square of the matrix elements of the amplitude of harmonic perturbing term and to the density of final state. It is given by density of final state. If the transition is from state n to k, then the number of transitions per unit time is proportional to the square of the matrix element of the amplitude of harmonic perturbing term with the density of final states. Here it is given that there are 3 states given by energy of E1 is greater than E2 is greater than E3, and the rate for E1 to E2 transition. So E1 to E2 transition rate means omega 1 2. So 1 to 2 transition is equal to E2 to E3 transition, that is omega 2 3. And also it is given that corresponding matrix elements means H prime Kn, like H prime 1 2. So 2 1 to H prime 3 2 is equal to 1:2. Now substitute the values and find out the ratio of density of the states. So here, if you consider omega 1 2, it will be 2 pi upon h cross h prime 2 1 square, density of final state, that is E2, then omega 2 3 is given by 2 pi by h cross h prime, here 3 2 whole square into density of E3 state, then omega 1 2 divided by omega 2 3 ratio, this and this cancels, then h prime 2 1 whole square divided by h prime 3 2 whole square into density of E2 state divided by density of E3 state. Given by, so value of this is 1, then value of this is, so 1 upon 2 whole square, that is gives density of E3 to density of E2 is 1 upon 4. Therefore option D is correct. A sinusoidal input voltage Vin of frequency omega is fed to the circuit shown in the figure, where C1 is greater than C2. Capacitance value C1 is greater than C2. If Vm is the peak value, here Vm is the peak value of input voltage, then the output voltage V0 is, so some circuit is given. During positive half cycle, D1 is forward biased. So if you consider this one as D1 and this one as D2, during positive half cycle, during here positive half cycle, positive part, so this becomes plus and this becomes minus. So since it is positive and negative, so D1 is forward biased and D2 is reverse biased. This charges the capacitor C1 to the peak value is Vm. So during positive half cycle, D1 is forward biased, therefore it charges the capacitance C1 to the maximum value Em. Then for negative half cycle, this becomes minus and this side becomes plus, then D1 becomes, Dm is reverse biased and D2 is forward biased. Since D2 is forward biased, it charges the C2 to the peak value Vm. Therefore, so during positive half cycle it is Vm, and during negative half cycle also it is, output is, so V0 is Vm. Therefore total value is 2 into Vm. Option A is correct. A sinusoidal input voltage Vin of frequency omega is fed to the circuit shown in the figure, where C1 is greater than C2. If Vm is the peak value of input voltage, the output voltage V0 is. So here it is mentioned that a sinusoidal input voltage Vin is of frequency omega is fed to the circuit. Consider this as diode D1 and this one as diode D2. During positive half cycle, this becomes plus and this becomes minus, which forward bias is the diode D1 and here diode D2 will be reverse biased. So therefore, because of forward biasing of diode D1, it charges the capacitor C1 to the peak value Vm. So that is for positive half cycle. V0 is equal to Vm. For negative half cycle, so this edge becomes negative and this becomes positive. So diode D1 is reverse biased and diode D2 is forward biased. Since D2 is forward biased, it charges the capacitor C2 to the value Vm. Again, V0 value is Vm because it charges the capacitor C2. Therefore, total output voltage is Vm plus Vm for complete one cycle. So value is 2 Vm. Option A is correct. If lambda m for solar radiation is 4753 angstrom, then the temperature of the photosphere of sun will be, lambda m is maximum wavelength, is given 4753, then the temperature of photosphere of sun will be. So according to Wien's displacement law, lambda m into T is constant, that is Wien's constant. Value of that is 2.898 into 10 raised to minus 3 meter Kelvin, and lambda m is given. You need to calculate the temperature. T is given by 2.898 into 10 raised to minus 3 divided by lambda m value, that is 4753 into 10 raised to minus 10. Since it is in meter, so it is also in meter, so meter cancels, so value will be 6097 Kelvin. Therefore it is near to 6100 Kelvin. Option A is correct. A 16-bit address bus of a microprocessor can support a memory size of, so in a microprocessor, n-bit address bus can support memory size of, for n-bit it can support memory size of 2 raised to n. So here it is mentioned that it is 16-bit, therefore it can support 2 raised to 16. It can support a memory size of 2 raised to 16. So its value is 65536. Option C is correct. A dual slope ADC, analog to digital converter, uses, so it is a direct question, it uses an integrator. In a thermodynamic system at equilibrium, heat can be partially converted into work, while the work can be completely converted into heat. This statement represents second law of thermodynamics. The data given below, x and y values are given. According to method of least squares, the desired straight line fit for the data is. So here for least square fit method, we have to find summation x, summation y, summation xy and summation x square. So here summation x is 10, summation y is 9, summation xy value is 25 and summation x square value is 30. Then from least square fit method, summation y is given by m into summation x plus n into c, where m is the slope, c is the intercept and n is the number of trials. Here value of n is 4. Substitute the value of these summation y and summation x. Summation y is 9 is equal to m into summation x is 10 plus number of trials 4 into c. Equation is 10m plus 4c minus 9 is equal to 0. Then summation xy is given by m summation x square plus c summation x. Summation x square value is 25 is equal to m into 30 plus 10 into c. That is 30m plus 10c minus 25 is equal to 0. Divided by 5 you will get 6m plus 2c minus 5 is equal to 0. Now we have to solve these two equations and find out the unknowns m and c. So m, c, 1. So coefficients of m in both equations are 10 and 6. Coefficients of c are 4 and 2. Then here coefficient of 1 are minus 9 and minus 5. And repeat this again. So 10, 4, 6 and 2. So cancel this. M divided by, so 4 into minus 5 minus 2 into minus 9. So 4 into minus 9 is minus 20 minus of minus 18 is equal to c divided by minus 9 into 6, that is minus 54 minus 5 into 10, that is minus 50 is equal to 1 divided by 10 into 2, 20 minus 6 into 4, 24. So therefore m divided by minus 20 plus 18, that is minus 2 is equal to c divided by minus 54 plus 50 minus 4 is equal to 1 divided by 20 minus 24, that is 1 divided by minus 4. Therefore value of m is minus 2 by minus 4, that is 1 upon 2. Then value of c is minus 4 by minus 4, that is 1. Therefore equation is y is equal to mx, that is half x plus value of c is 1. Therefore straight line fit equation is y is equal to x by 2 plus 1. In a gas, the expression for average speed of a molecule is given by, here the relation between RMS speed, mean or average speed or most probable speed is like this, that is 3 kt by m, square root of 3 kt by m is greater than 8 kt by pi m greater than 2 kt by m, where average speed is 8 kt by pi m. So therefore it should be pi m. Option C is correct. Two ends of a rod are kept at 127 degrees Celsius and 227 degrees Celsius. When 2000 calories of heat flows in the rod, change in entropy is. So here change in entropy is given by delta S is equal to delta Q, change in heat energy, divided by delta T, change in temperature. Here heat energy is 2000 calories divided by change in temperature, that is 227 minus 127 degrees Celsius. So it is 2000 calories divided by 100 degrees Celsius. Therefore 20 calories per degree Celsius is answer. Otherwise it is given by 20 calories per Kelvin. Option B is correct. In a classical micro-canonical ensemble for a system of n non-interacting particles, the fundamental volume in phase space, which is regarded as equivalent to one state, is. Here it is mentioned that the particle is in phase space. The coordinates of phase space are position coordinate x, y and z and momentum coordinates px, py, pz. Phase space is a 6D space. So here from uncertainty principle, uncertainty in position coordinate into uncertainty in momentum coordinate is always greater than or equal to h cross or h. So here similarly dy into dpy is greater than or equal to h cross and dz into dpz is greater than or equal to h cross. Therefore, the volume element in phase space is given by dx into dy into dz into dpx into dpy into dpz is the volume which is always greater than or equal to h cross cube. Therefore, a point in 6D phase space is considered to be a cell whose minimum volume is of the order of h cross cube. Hence, for a system of n non-interacting particles, the fundamental volume of phase space is regarded as equivalent to one state if its volume is h cross cube raised to n, that is for n non-interacting particles. So that is h cross raised to 3n, or it is simply h raised to 3n. Therefore, option A is correct. In an experiment, the acceleration due to gravity g is determined by measuring the time period of a simple pendulum. If there is an error of 1% in the measurement of time period, the error in the value of g is, for the simple pendulum, the time period t is given by t is equal to 2 pi into root L by g, where L is the length of pendulum and g is acceleration due to gravity. Here we have to find the error in the value of g. Here error in the value of time period t is given by delta t by t is equal to, here since 2 pi and L are constant, we have to consider only g. So 1 by 2, since here it is square root, 1 by 2 into delta g by g. Delta g by g is error in the value of g. Delta t by t is error in the value of time period t. So therefore 1% is equal to 1 by 2 delta g by g. Therefore value of error in the value of g is delta g by g is equal to 2%. Therefore option A is correct. A modulus 12 counter must have, so you know that n number of flip-flops in the counter counts 2 raised to n natural counts. N flip-flop always counts 2 raised to n natural counts. For example, only one flip-flop counts 2 counts. So 2 flip-flops counts 4. 3 flip-flops in the counter counts 2 raised to 3, means 8 counts. For 4 flip-flops it counts, so 2 raised to 4, that is 16 counts. Therefore mod 12 counter must have at least 4 flip-flops. Option C is correct. In a serial in serial out shift register is used for a time delay of 24 microseconds. The clock frequency applied to the flip-flop is, so here clock frequency applied to the flip-flop is given by f is equal to number of bits divided by time delay. Here it is mentioned that it is a 8-bit serial in serial out shift register. Therefore number of bits is 8 divided by time delay is 24 microsecond. Therefore 8 by 24 is 1 by 3 into 10 raised to 6, which gives 333 kilohertz. Option B is correct. A JK flip-flop with J is equal to 1 and K is equal to 1 has a 10 kilohertz clock input. The Q output is, so the truth table for JK flip-flop is, it is a clock, then J, K, value qn plus 1. Initial state, then clock pulses. So when j is low and k is low, when j and k both are low, it remains in last state only. The output will be qn only. When j is low and k is high, the flip-flop resets to 0. When j is high and k is low, the flip-flops sets to 1. When j is equal to 1 and k is 1, that is j and k both are high, it go to toggle state. Means if it is 1, the initial last state is 1, it will go to 0. If it is 0, then output will be 1. Therefore, so given that when j is equal to 1 and k is equal to 1 and 10 kilohertz clock input is given. If it is a qn, then qn bar is the output. So it is a square wave only. Therefore, option C is correct. The gauge transforms of A and phi satisfy the Lorentz conditions if and only if the gauge functions themselves satisfy. Here, the Lorentz condition for gauge invariance is given by del dot A plus mu epsilon dou phi by dou t, where A is vector potential and phi is scalar potential, and this condition is said to be Lorentz condition for gauge invariance. If del dot A is equal to 0, then it is said to be Coulomb gauge, and if del dot A is equal to minus mu into epsilon dou phi by dou t, then it is said to be Lorentz gauge. Here both A and phi should satisfy the wave equation given by d lm by Tn square A is equal to minus mu j and d lm by Tn square phi is equal to minus rho upon epsilon, where d lm by Tn square means del square minus mu epsilon dou square phi by dou t square. Similarly, the electric field vector and magnetic field vector B both should satisfy the wave equation. This d lm by Tn square E is equal to 0 and d lm by Tn square B is equal to 0. Therefore, here question is gauge transforms of A and phi satisfy Lorentz condition if and only if the gauge functions themselves satisfy the wave equation. A program accesses 10 continuous memory locations. The microprocessor will take less time if the addressing mode is, answer is direct. Thanks for watching. Hope you like this video. Kindly subscribe and share and keep watching.